Oh, well, there's two triangles glued to each other. Oh, and what do we see? The one student who should look at this and perk up with glee. What do we see?
Oh, you're not going to say it, are you? I'll tell you what I see. The Santiago Special. That's right. I see the Santiago Special right there. Boom, boom. Although it's not as obvious, it tells us that these guys are congruent. But although it's not as obvious, since these lines are parallel, these angles are congruent. So I, at this stage, and you, for sure, maybe leading up to it, you weren't so sure. You, at this stage, should be able to say, all right, I have an angle, a side, in between another angle. Which of the four postulates that we learned is this? An angle, a side in between, and an angle shows us that these guys are congruent. Let me open up my chat. Camilla, you are right that that's the name of it. But we always call it the Santi Special. What three letters? It's either SSS, ASA, SAS, or AAS. Which of those four could I use to prove that this triangle on the top is congruent to that triangle on the bottom? SSS, ASA, SAS, AAS. ASA is correct because we have an angle, the side in between another angle. And so angle, side in between another angle. That looks awful. Ms. Harris, I'm really contemplating buying one of the little pad things that you guys have. Unless when we come back in person, they have like brand new computers for us. I'm pretty much over this whole touch screen. I'm over it. All right. I'm sorry, Bob, but I'm still looking for Mr. Right. Oh. It's funny. Oh, poor Mr. Right, or poor Bob, just because he's a little different. Let that be a lesson that you're not allowed to be any different. We're going to talk about right triangles. And what we learned yesterday are four postulates called S, 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 A, S. That was 3 days ago. And then yesterday was A, S, A, and then A, A, S. Again, I'm looking at these two triangles. Here they are. That side, that side, that side is the same as that side, that side, that side, S, S, S. That side and the angle in between that side is the same as that side and the angle in between that side. That's SAS. That angle has a side and then another angle, and that's the same as that one, ASA. That angle over there and that angle over there, and that side not in between is AAS. Now, fortunately, we live in a world where we have special types of triangles called right triangles. And so with right triangles, the right angle is given. So I'm allowed, so if I give you a triangle like this and a triangle like this, right? And I tell you that those two sides are the same and those two sides are the same. Traditionally, we would look at this and say, oh, well, that's side, angle, side. That's side, angle, side. And so SAS would be the reason why that makes sense. Well, math just loves to overcomplicate things. And math people are like, you know what? Let's just come up with 4 brand new terms for right triangles only and make kids memorize things more. That's what we're doing today. Now, if you forget these 4 new names that we're going to learn today and instead use this guy, then you're okay. But, if you're like, oh man, I love using less letters, then boy, do I have some fun, exciting surprises for you. Well, something called leg congruence is literally what I just did. The three sides of a right triangle are leg, me writing sideways, leg, and hypotenuse. I'll just abbreviate that as hype, which is slang for getting excited. So in the previous problem, and by the way, this is a right triangle. So if I'm looking at two triangles, right, I'm going to go back and I notice, oh, that leg is the same as that leg, and that leg is the same as that leg, I could be done and say they are congruent due to the leg congruence. Or I could just say LL, like the rapper LL Cool J, or the clothing company LL Bean. Now, this next one really makes me laugh because the abbreviation is HA. Now, the way you use this one is if you notice that, oh, look, the hypotenuses held. Sandy, leave me alone. I'm allowed to be happy, okay? This one is a play off of AAS because I have an angle and the side that's not included. Or if you're like, oh, that's a right triangle. So look at that angle and look at the hypotenuse. If the hypotenuse is, it's either hypotenuses or hypotenusae. I'm pretty sure it's hypotenuses. If the hypotenuses are the same and you have some random angle that are also the same, you could use HA. You could use HA. No, I am not 15, Paul. If I was 15, can I grow a sweet mustache like this? I didn't think so. And I offended Megan. I'm sorry, Megan. Those of you who live in a large city in California would love this one. So this is the same as HA, but it's LA. And this is a play off of the angle side angle. And you have a side with two angles on the outside. So you have a side in between two angles, ASA. But we're like, nah, this is a right triangle, and that is a leg, and that's a random angle. So let's call that la. All of you singers would love this. Hypotenuse leg congruence is a play off of one that we haven't learned yet. So that's okay. This would be a play off of the curse word. But we're allowed to, this is special. This is a special case for right triangles. Hypotenuse leg, if the hypotenuse and a leg and is congruent and it's a right triangle, then you could use HL. All right. So let's rewrite those out. We have leg. We have ha. We have la. And we have HL. I have to look at problem one and compare these two triangles. They're right triangles. You should be able to say that thing is the same as that thing, and that thing is called a angle, leg, hypotenuse, whatever. And also that thing is the same as that thing, and so I'm inclined to agree with Keon here. This is LA, because you should be able to say that's a leg and that's a leg, so that gets rid of you. That's an angle, and that's an angle. So I need the one that is leg angle, and it's LA. What's two? What two things in common do you see for that one? Oh, what's so funny, Athena? This is so much fun. I haven't laughed at anything more than I have laughed today with my very good friends. Good job, Camilla. The hypotenuse is the same as that hypotenuse. And then that random angle that's floating around is the same as that random angle that's floating around. The only one of these four that include a hypotenuse and an angle is ha. And of course, you can only use these if you notice that they're right triangles. So let's do some proofs. 2 of them, and then we're going to call it a day. Those of you who I know yesterday I had you watch, or I asked you during asynchronous time to watch the video on SSS and SAS. I uploaded the ASA and AAS this morning, like halfway through the morning. So you probably haven't had the opportunity to watch that yet. But that included like several proofs. And these are no different. What you're looking for is it gives you information, and based off of that information, you should be able to say, okay, well, that thing over there and that thing over there are exactly the same, and that thing over there and that thing over there are exactly the same. And oh, look, those are right triangles, and therefore I could use either this, I could use either this, or I could use either this, or I could use either this. So let's write out our given. Or reasons, statements and reasons, got it backwards. First reason and statement, always the given. So we have FH is perpendicular to EG. The next line is the bisect one. FH bisects EG. FH is congruent to EG. So that's what gives us the right angle. So we have to say that. Or it's perpendicular. I keep saying that. So I'm allowed to say that angle FHG and angle FHE are right. And that's the definition of perpendicular. I have to say that. It's not as obvious, but that's why we do this practice. Definition of perpendicular. Upside down T means perpendicular. So that takes care of that part. Now, since FH bisects EG, I could say that GF is congruent to FE. Let me use a different color. GF is congruent to FE. That says GF terribly is congruent to FE. And that is the definition of bisect. This is so unbelievably laggy. Do I have another thing open? No. I guess I don't need my email open anymore, so we'll close that. Definition of bisect. Nope, that didn't help at all. Wow. That's supposed to say the definition of bisect. Okay, so by doing this, so let's look at the picture. We have a side, we have an angle. I need one more thing. What's one more thing that I can say is congruent? Even though it doesn't tell me that, what's one more thing that I can say is congruent? And this one thing seems to happen in almost every single problem that we do. HE and HG. We already did that, didn't I? Oh, I did the wrong thing. Athena's right. Erase that. I'm sorry. Those of you who actually are taking notes, erase that. Athena's right. That should be HE. And HG. Athena, good job. Athena wins Student of the Month. It's my pleasure. Well, this always seems to happen, and the person that really should be speaking up isn't speaking up. I have two things. Right now, I have my right angles. I have legs that are the same. What else here is also the same that we haven't mentioned yet? That all I have to do is look at my picture. It's the Santee Special. So FH is the same as FH. And what's that property? Reflexive property, says Camilla. Really should have printed this out and used my document camera. The me, says Santiago. So now I have GH and HE, which are legs. I have FH, which is also a leg. I can now say, and I'm going to write it as best as I can, as small as I can now say that triangle EFH is congruent to triangle GFH. And that's using which one of these properties or which one of these postulates? Just type it out. Either LL, HA, LA, or HL. Which postulate says that I can say that these guys are congruent? LL is correct. So backing it up a little bit. I should be able to, this is very similar to these problems back here a little bit, but these problems are glued together. So I should be able to say, all right, well, I need to prove that these guys are the same. So I need to explain why these are right angles. I need to explain that these guys are congruent to each other. That's a leg. And since these are the same exact side, then those are congruent to each other. That's also a leg. Therefore, I can prove that these guys are congruent using the leg-leg congruence postulate. The leg-leg congruence postulate. The OL. Or those of you who speak Spanish, the ya. Lily gets it. Thank you, Lily. Thank you, Camilla. Thank you, Santiago. All of my Spanish-speaking friends seem to understand it. The non-Spanish-speaking friends are like, that's not a why. Oh, we have fun. Speaking of fun, one more problem, baby. All right, look at all this space that I get to use. Statements. Reason. All right, so this is what we're given. We're given AD is congruent to BC, and that's nice. A and C are right angles. So that's perfect. This is actually a ridiculously much easier problem. So let's do the old squiggly for the given. Okay. It tells me this. It tells me this. That's good news. It tells me this, and it tells me this. That's also good news. Yay, Jill! Yay, Jill got it first. I did the fun word of the day. Hooray for Jill. All right. This is the part where I look at the screen and see that Russell is not paying attention because he didn't close out. Bad Russell. I'm going to call your brother up. All right. Mine didn't even load. Lies. Okay, so there's our given. We were told this. That's good news. We were told this. That's good news. Well, I have my right angle. I have a leg. What else do you notice? What else do you notice are exactly the same? What else do you notice that's exactly the same? What else do you notice that's exactly the same? The Santiago special. Pew, pew. We could say that BD, oh my goodness, that BD is congruent to BD. And that's called the what? Or DB. You can do that too, Paul. I just avoid that acronym. Reflexive. I have a right angle. These two sides are congruent, and this side's congruent to himself. So now, I can say that triangle ABD is congruent to triangle CDB, and that's through which one of the four properties? HL is correct. Because the hypotenuse is the same. Oh my gosh. It's because your guardian is still up. The hypotenuse is the same and the leg is the same. So this is going to be the HL property of congruence. Bada bing! So if you feel really comfortable about the last two sections and those proofs, then this shouldn't be too bad for you. Not too bad at all. All right, let me get Jill's name up here. Jill P for Jill Patel. And that's it. Good work, everybody. What postulate would you use for this proof on the right? Oh, it's HL again. I don't know if Lily... I just looked in the fact that it's the same as the last one, and since Lily answered the last one, I saw HL up there. It's HL again, because the hypotenuse size and the Santi special leg are the same HL.